A2 Maths, small angles. I'm going to show you something that applies to small angles and the sine, cos and tangent of these small angles. So the first one I'm going to look at is sine theta. So sine theta, if theta is quite small, then sine theta is approximately the same as theta. Now that sort of makes sense because if you think about the sine graph starts at 0 and goes up like that and goes down. Now where it's very small, in this region just here, the sine function pretty much is the same as y equals x line. It goes up at 45 degrees. So if you imagine you've got a really small theta value just here, the value you get is pretty much the same because y equals x. It's roughly the same. So whatever theta value you got, sine theta is approximately, that's what this means here, approximately the same angle. So sine of something really small, let's say it's sine of 1 degree, it's approximately the same as 1. So sine of 2 degrees is probably approximately the same as 2, and so on. Once it starts getting bigger, sine of 30 degrees, then it's not the same as 30 anymore. Right, cos function. Now I wouldn't blame you at all for thinking, well, the cos function looks like that and comes down. So surely for a small angle, it's just going to be equal to 1, isn't it? It's 1 degree, roughly equal to 1. 2 degrees, roughly still equal to 1. I wouldn't blame you for thinking that, but it's not quite that simple. The cos function is approximately equal to 1 minus the angle squared over 2. That's because 1 is where it starts, but then it starts to go down almost straight away, right? So it literally starts descending straight away. So it's not quite 1, but you take away just a very small amount of this, okay? Right. Also, you'll notice that these things only work for radians. So they're only working for radians as well. Because if you put 1 degree into this, 1 minus 1 squared over 2 is a half. 1 minus a half. That's completely wrong. Because if you look at that cos graph again, you'll notice that 1, that's 0 degrees there, that's 9 degrees there, 1 here clearly doesn't equal a half. Okay, but 1 degree in radians would be very small and would get you approximately the right answer. Okay, what about tan? Well, the tan function, again, is approximately equal to theta. And the same reason as sine, if you think about the tan graph starts there, goes up, hits an asymptote, and so on. So it's an asymptote just there. And it does the same on this side. So there's your tan graph. But just in the middle, when it's small, this graph is roughly the same as y equals x. So a small angle gets you exactly the same because it's roughly y equals x. So it's only the cos graph that seems to just cause a bit of a problem there. Right, the actual way these are formulated, where they come from, is something called a power series. But the truth is, the power series is beyond the scope of your course. So you do not need to worry about where they come from, and in fact you get given them as well in the formula book. The other thing that's worth noting is that multiples of these angles that are very small can be assumed as well. For example, if I had sine of 2 lots of a small angle, then it's approximately the same as that number, that small angle. And the reason why that's true is because if you imagine that that's very, very small, then even if you times it by, let's say, 3 or 4, it's still going to be very small. Okay, there needs to be a bit slight proviso that n isn't too big. Okay, so it's no good having n as a million, because then that number won't be small anymore. But as long as n times that theta value is still small, and the examiner will let you know if it's still small, then it's approximately the same. Same with this one. Noticing you're just substituting the n theta in for the theta part. Just be careful with the squared there. And the same for tan. That's exactly the same. Okay, so give you a chance to get those down in your notebook, and then we'll see where there's pretty much only one place the examiner will expect you to use them. But we'll look at 2 different examples. So if I want to find an approximation for f of x equals 6 lots of 4x tan 2x, where x is very small. So the examiner's giving you that hint. That's what you're looking for. X is very small. The angles are very small. Now, because he's telling you it's very small, you've got your formula books. You'd make sure you've got the right formulas and you'd use this. So what do we have? Well, because x is very small, we know that cos 4x is exactly the same as 1 minus 4x squared over 2. Okay, tan 2x, which is that part, is exactly the same as 2x. So that's me using those formulas. Now all I'm going to do is take those two parts, 2x, substitute it into there, and I'm going to take the cos 4x, that part, and substitute it into there. So what do I end up with? 6 cos 4x tan 2x. So it's 6 lots of the the cos 4x part, times by the 2x, which is the tan 2x part. I can do a bit of simplifying. You can see what I've done there. I've done 4 squared is going to be 16x squared all over 2. So that's where the 8x squared comes from. I get to that part and I could write it out as 12x minus 96x cubed. That would be my approximation. That is exactly the same, approximately the same as that when x is very small. Okay, so if you had a very small radians, you substitute into there, you'd get approximately the same value of that. And you could try it on your calculator now. You could get your x value, go for a very small x value, set your calculator to radians, try typing in something like 0.02, something like that. Do 6 cos 4 lots of 0.02, tan lots of 0.02, and then just check it gets exactly the same answer with that. And the answer should be yes. Okay, so the other area that's a more likely case of it coming up is showing how you differentiate sine and cos. Okay, so we're going to look at how you differentiate sine and cos. So you know how to differentiate sine and cos because you've seen those before. So what we're going to look at is how you prove where those come from. So if I want to differentiate sine, I can first of all notice that this first part using the formula for differentiation from first principles, I notice that sine 2x plus 2h is exactly the same as a compound angle. So I'm using the correct compound angle formula, which I've got just there. I am now putting the parts in there and there. Why am I doing that? Because we know that if you're using this, you're looking at h tending towards 0. H is very small. So because h is very small, that means that you can use a small angle approximation for the cos 2h and the sine 2h. Now the x value can be anything. So what you can't do is you can't do an approximation for that. We can leave the cos 2x and the sine 2x, but the cos 2h and the sine 2h, they're the ones where we can use a small angle approximation. So what does that get me? Well, if I expand this out, I'm going to get sine 2x there. I'm going to get 4h squared over 2, that's where the 2h squared comes from, and this bit would be 2h cos 2x. So I've expanded it all out. That is my numerator, just there. So there's my numerator, and there's the expanded version of it. Notice this first bit just here was this. Okay, so those bits there. Right, so what happens now? Well, the sine 2x and the minus sine 2x will cancel each other out. The h part there and the h part there will cancel with this h underneath. So I'm ending up with minus 2h sine 2x plus 2 cos x. Now as h tends towards 0, that means that h value there is going to get really, really small. That means if that gets really small, minus 2 sine 2x is going to get really, really small. Doesn't matter what values they are. H is ridiculously small. So unless you times it by those, the whole thing will be very, very small. So what would I be left with? 2 cos 2x, which is the differentiation of sine 2x, which is where we started from. So what I'd like you to do is just have a go at some of the exercises on 2.1. There's not many, so it's worth having a go at them all just to practice those small angles approximations. But if it does come up in your exam, it's most likely the examiner expecting you to show how to differentiate sine and cos from first principles.